we switched the speaker. My name is Hyoseop. Then I'm working at Encored Technologies, leading technology team there. I'm very happy to share my experience on the NILM at the NILM workshop, which I attended the workshop 2014 in Austin, and then 2 years later, finally I got something to share with you guys. This is about my experience on the commercialization of NILM. We already serviced to the NILM service to 10,000 residents in Korea. That is the 10% of our total deployment, our metering device in Korea. Before we start about talk about the technology, I want to briefly introduce my company to you guys, so that you guys put the name Encored when you draw the positioning map, please. Yeah. So our mission is very clear. Our mission is to collect energy data in the world as much as we can, so that we can make it accessible and useful to everybody. On the top of the data, we believe that we can solve the problems in the energy field in a better way. That's why we are collecting all the data in the field. As of now, we have 56 members are working for the company. Interestingly, only 2 guys majored electricity, the energy, and all the other guys came from the computer science, mathematics, like me, and statistics. So far, we got funded $16.5 US from the Formation 8, Samsung, LG, and Neighbor, which is very famous for the mobile chatting app, Line, and the other renowned companies. One of the biggest investor of our company is the George Soros. He invested $11 million to our company. That's just because of energy data. He believed that the energy data can change the world in a very different way. So we are doing very well, right? We are operating 4 offices in 3 different countries: the States, and Japan, and Korea. In Palo Alto, we have a holding company, and in Boston, we have a research center. In Japan and Korea, we have the marketing and sales and development team. So let's say about that technology. So this is my experience for the commercializing the NILM technology in the field. Actually, the NILM algorithm itself is just a part of the production, right? In my opinion, there are 4 different layers for the production of the NILM. The first one is collecting data, and the second one is saving and managing the data, and the third one is analyzing the data. That is NILM. And the last one is just serving the data. If we think of just free app for the energy, then I think that just like some number of hours as a failure, it could be okay to end users. But if we think of utilities, then it may not be acceptable to those guys. So we very carefully design the architecture of the system so that to minimize the downtime and system failure. There are our main features of the system. The first one is that auto scaling, and the second one is the intelligent naming service, and the last one is optimization for the measurement data. Using these kinds of features, we reduce the downtime of the system, and we very quickly manage the data in the raw format. So if I explain a bit more, then the right-hand side, this is something like the computing cloud that they calculate all that measurements, and then the left-hand side, left part, is the analytic cloud that store all the raw data and then analyzing that data. I have plenty of time, right? Okay, I think everybody used that the AWS, Amazon Web Services, right? The problem is that the AWS is really expensive when you're saving the raw data and analyzing data. So we maintain that the hybrid type system. So all the data goes to the AWS, but the raw data, we manage the raw data to the on-premise server system. To the store the raw data, the formatting the raw data is really expensive in the AWS. So we build our own server system on premise, and then we also apply the physical computing resources like the GPU that the on-premise servers. So the 15 or the hourly data is stored at the AWS, but the second data, every second data is stored on the on-premise servers. Okay, everybody is focusing on that slide. So the reader, in my opinion, as a mathematician, NILM is not well-defined problem because we have to find too many things when you're solving the problem. So the basic thing, the fundamental thing is nobody knows how many appliances exist at home, right? That is the biggest problem, biggest challenge. So we just focus on the limited number of appliances, and we just focus on just target appliances which is very relevant to each country. You know, kimchi fridge? Nobody knows, right? I'm from Korea. So the kimchi fridge, the penetration of kimchi fridge in Korea is over the 90%. So kimchi fridge is very important in Korea, but the other countries, that's not, right? So we focus on the limited number of appliances at each country. So we are focusing on these appliances at this moment because we are delivering service in Korea and in Japan. So fridge and rice cooker and washer, TV, AC, and microwave. Those appliances are main focus of us. We have two different algorithms. The first one is event-based algorithm. That is a very well-known algorithm, right? So just we are checking that the rising edge and the falling edge and the match that the event. That is very easy and very well-known. But there's a difficulty, right? How we define the edge, what is rising and what is falling. And also, the clustering itself is very difficult, right? So we add one more feature, periodicity. So we only use this algorithm for the 24-hour cyclic load, like the fridge. Because the clustering itself is too difficult. If you don't have additional information like the periodicity, we cannot solve this kind of problem. So we add periodicity, then we can solve the well for the fridge type appliance. So this is a step for the event-based detection. First, we detect the rising and falling, and then clustering all the edges and match the edges rising and falling without the feature of periodic scheme. The second algorithm is the operation pattern-based algorithm. Because we only focus on the very limited number of appliances such as washer and rice cooker and some other devices. As you can see here, this is the rice cooker's pattern, the upper one. The bottom one is the washer's pattern. As you can see here, there are very specific patterns, right? We cannot detect the rising or falling edges, but we can see what is the unique feature of such appliances. So we build a model for each appliance, and then we see the total load, whether the total load is matched with the model or not. If the model matches with the load, then we extract some additional information, like what is the consumption and what is the duty cycle inside of the operation. The last one is very recently developed one. This is based on the deep learning because we get really many data. So we realize that the deep learning can do better than what we have done because we get more data and the deep learning can do better than before. So this is just a typical structure for the deep learning. But only the difference is that we have more data than others from in-house database. When we're calculating the performance of NILM, there are many metrics. Among the metrics, we only focus on the limited number of the metrics. We divide into 3 different categories. One is event-centric, and then the second one is the UC-centric, and the last one is event and UC-centric. Especially for the event-centric, we are thinking that the consumption of such appliances is not important to users, right? Rice cooker, washer, microwave, TV. Those guys, the UC is not that important. So we may focus on that recall and precision as a metric for such appliances. But for fridge, nobody care about the recall and precision, right? So we only measure the usage, energy usage. But for the AC, everybody wants to know when they turn on, turn off, and what is the usage. So we divide into 3 different categories, and then we optimize what is the best method in terms of these different measures. We release our performance metric on our website. If you go to that site, then you can see our performance metric. From June, we have been doing some tuning work for the NILM in Japan market. So from the June, we have the historical result for that each appliance. Unfortunately, this is in Japanese. So let me teach you Japanese right now. Ohayo gozaimasu. It's just kidding. So this is the NILM, the performance in Japan market. If you see that washer, the August result for recall is about 50%, and then the precision is like 70%. The recall is not good. That's because we only model like a washing, but that washers include the dryer, so that's why the recall is relatively low than the precision. If you see that the rice cooker, the August result is about 75%, the precision is 97%. It's quite good. For the TV, this is the result from the deep learning. Recall is 93, and then the precision is 65. we need the tuning work for the balance between the recall and precision. That is true for the AC too. So for the deep learning, always that the trade-off, there is some trade-off between the recall and precision. We need to do some tuning work. For the microwave, the recall is almost 100%, but the precision is 50%. We need still some kind of the tuning for that such kind of the balance. For freeze, in terms of the energy usage, it's about more than the 80%, which satisfies the result. Those numbers does not give any sense to you guys, right? So this is graphical illustration of our performance matrix. As I mentioned, rice cooker works very well. So I take the example from the rice cooker, right? So this is the result from the rice cooker. Each box represents the home and the date. So each column represents the date. Each row represents the home. The upper box, the upper part of the box is direct measurement, and then the bottom one of each box is the evaluated value by NILM. So that the red one, they represent event. So for home 1, I randomly picked the homes. This is not intended there. So anyway, for home 1, home 2, home 3 is perfect result, right? For the home 4, nothing happened. For home 5, we failed to find for the 25th September. For home 6, we cannot detect for home. So we are focusing on that. We are more emphasis on the precision rather than the recall, because if we give us some information to everybody, if something is wrong, then the people does not trust. So we are more emphasis on the precision at this moment. I think if you guys the interest in that visualization of NILM, then I think this kind of the illustration works very well. So we provide service to end users using this kind of mobile app. So that this is the first main page of our app. So it shows that the usage pattern, daily usage pattern at the top, and there are tile menu that give us some insight before you click the menu. We provide the real-time usage and the bill every second. And also we provide family care service. That is very interesting. So if you register your family, then of course the family has to have our device. Then we can show the family members' usage pattern and what kinds of the appliance they use. From this example, the family, my parents, use that washer and the rice cooker and TV, but didn't use AC at that date. So I can see my parents' activity based on that NILM. The third one, that is the timeline. This is kind of the energy tip based on that NILM. And the first one, that is the energy breakdown service. This is NILM service. So this is the daily clock, and then it represents when I use that appliance. And the other one, that is the demand response service based on that NILM. So we know what kind of appliance the consumer use at the specific time. So we can provide energy tip when we give us some instruction for that demand response. The last one is that the kind of the energy planning tool that summarizes your usage pattern monthly. If I finish my talk here, I'm sure that the organizer will tell me, right? This is DATASETS section. So I add this section. We thought data is too important for the commercialization. When I started this work, there's no data. Actually, there's like a red data. But I'm working in Korea. The red data does not work at all to me. So I need to gather data. So we design software and hardware together. Only to collect data. That is the smart plug type D device that collects each appliance's data. So I connect these kinds of device to like the fridge, rice cooker, washer, and TV and AC. And also provide some mobile app that shows that each appliance's usage and some kinds of additional controllability based on the smart plug. For home panel, we also make some kind of the metering device. We connect this device to main panel, and if you are interested in that salt either, then you can add more. Then we collect all the data, and all the data goes to our server. We have some rule when we collecting the data. Total load should be monitored. That is basic, right? And in average, we want to monitor at least 5 appliances at each home. The target appliance could be different by country. And when we recruit the house, we only choose household whom we can ask about appliance. What is the type of appliance? What is the model number? What is the size? What is the consumption? So we have the specification of each appliance very detailed. And we monitor the status of the network and then the function of these devices. That is also very important because I need to call those guys that your device doesn't work at this moment, right? The reason why we made those kinds of apps is that the problem when collecting data in real field is that nobody does not like such things. I have more than 10 devices in my home, and my daughter and son try to grab those things, and then this is really dangerous sometimes, right? So the house owners, just 1 month later, they want to pull out every devices. So that's a big problem to us. So I want to deliver any value to customers. To get cooperation from end customers, you have to deliver, you have to give any value to users. If you just say, I need data, so please help me, it does not work. Just 1 month later, nobody likes it, right? So they provide a small app, but this is showing that what is your appliances usage and what is your bill for this appliance, and then you can turn off and turn on this one. It gives us little value, but we want to give us just little value and must, so that so that we can retain the customers for the data source. So far, we have the fixed live data set for more than 150 homes. In average, we have each home has 5 more appliances. In average, more than 6 months long data span. And every second, we have 10 points active and reactive power. We have the expansion plan. So by December of this year, we will add 100 more homes. And we are servicing at this moment 10,000 homes. So we have the total data for more than 10,000 homes as well. We prepare to open some parts of our data set. You guys, we talked about the privacy and the other things we have to be the word, right? So we need to start very small steps, like a TB. So I think TB does not reveal specific users' behavior. So that tells something. Well, actually, this is not called the usage pattern. So we start with the TB data set first. Only for that, I get 20 homes and 1 month long data span, time span, and then there will be the 10 points every second with an on and off label about the TB. Here's something, the terms of use. So data should not be used commercially. And to publish an article based on the data set, a proper reference should be provided. The data should not be redistributed in an original form nor a modified form. That is the main terms of use. That's it. So we are preparing to open the data set. I think before this year we can open the data. I think this month or hopefully next month we can open the data. So I will tell you to the organizer how the guys can obtain the data. So thank you.